All right, so we did vectors last week. Today we'll do a little bit of calculus because eventually we will be linking vectors and calculus together. Calculus is just finding the slope. So this topic is called calculus. Essentially what it is the slope. We use the word rate of change. We have done this in the past. There's two types of rates of changes. The first one is called the average rate of change. ROC means rate of change. Let's say you have a curve like this. You have one point A, you have another point B. We connect them using a straight line. This line will have an equation in the form of y equals mx plus b. What we're interested when we're finding the average rate of change is this m value, which would be the slope of this line that connects these 2 points. Usually we would have the coordinates of these 2 points. So let's say we have x1, y1, x2, y2. How do you find the slope using coordinates of 2 different points?
You do rise over run.
Yeah, exactly. You can just do rise over run. Y2 minus y1, x2 minus x1. So that'll give us the slope. It's pretty straightforward. So that's the average rate of change. On the other hand, you can have instantaneous rate of change. Now this is not between 2 points. This is strictly at 1 point. So now you only have 1 point, A. What instantaneous rate of change is the slope of the tangent line. Now this is important. This line that we use to connect point A to point B, this is called a secant line. That's the name of this line that connects 2 points. Average rate of change is the slope of the secant line. Whereas instantaneous rate of change, you only have 1 point. What you do is you draw a line that is perpendicular to this curve at this point. Now that's a mouthful. So what does that even mean? It means kind of draw like a 90-degree to this curve, and then you can draw a line. And this tangent line will always just kiss or just touch it. It's not going to cross it. It's just going to touch that point and go through it. At this point, this tangent line is perpendicular to this point on this curve. So this is the tangent line. When we're talking about instantaneous rate of change, we are attempting to find the slope of this tangent line. Notice how both of these lines are linear functions. Secant line is also going to be in this form. Tangent line, if we can find that, will also be in this form. Now, finding the slope of a tangent line is slightly more difficult because you only have 1 point to work with. So for the slope of a tangent line, what we do is we use the limit method. This is also called difference quotient. We'll do a bunch of these examples in a bit. It's also called the difference quotient. And this is the formula. Limit as h approaches 0 of your function f of x, but what we do is we add a certain h element to your original function. So if you had f of x equals x squared, f of x plus h means you just replace the x inside of this function with x plus h, like this. A more complicated example would be something like this. Let's say you had 2 sine x plus 3 squared, something like this. Now in here, fx plus h. Again, it's very simple. Even if there's multiple x's, all you do is you look at where your x's are, and only those x's, you're going to replace them with x plus h. So for this, it would look like x plus h plus 3. Just replace that x with x plus h. Squared, and again, the other x here on the side also becomes x plus h. So that's what fx plus h is. In reality, theoretically, what this h is actually it's not 0, but it's approaching 0. So we're essentially just adding 0 to our original function. Why do we do that? It's because we need to figure out a way to cancel this h in the denominator. And this is the formula that we use for calculating the slope of a tangent line. You don't have to do this all the time. There's usually shortcuts, especially if you have a polynomial or something like this is an example. If you have 2x cubed, let's say this is your f of x. IROC means f prime of x. This will give you the slope of the tangent line. Let's say the question is, this is your function, find IROC at x equals 1. Now that's a cubic function. We don't have to draw it if you don't want to, but it's always helpful. It's a positive cubic function, starts in quadrant 3, ends in quadrant 1. Kind of looks like an S. The 2 in there doesn't do a whole lot. It looks very similar to the parent function x cubed. The 2 is a vertical stretch, but in terms of the diagram, it looks very similar to the original function. So what we're trying to do is at x equals 1, what's the y value for this function when x is 1? What's f of 1? You just want to replace the x with a 1.
It's 2.
It's 2. So when x is 1, y would be 2. There's our point right there. What we're trying to do is first we draw a tangent line at that point, and that's perpendicular to that curve. We are trying to find the slope of this tangent line. What is the m value? For a polynomial, it's fairly easy. If you use a shortcut, this is bulletproof. This will always work. This works for any function. If there is a derivative, is what we called IROC, is also called slope of the tangent line, is also called derivative. The difference quotient method always works for any function. But if you have a polynomial function like this, which is in the form of, let's say, k times x to the power of n. K is 2, and here's the power, it's 3. The shortcut method says f prime of x, you first bring this n down to the same level, so it becomes n times k, and then you take 1 away from it, like that. So this is the shortcut for polynomial functions. What would be the derivative of 2x cubed if we use this formula?
6x squared.
That'd be 6x squared. And then what you do is, we're interested at x equals 1. We do f of 1, f prime of 1. So the slope there is 6. 6 times 1 squared is just 6. And there we go. That's the answer to the question. Okay?
Mm-hmm.
So average rate of change, instantaneous rate of change. It gets trickier as we move into it because the shortcut doesn't always work. Let's look at this function. 5x squared minus 8x. Is it opening up or down?
Up.
Up, right? So you don't have to do it. Actually, does it say graph it? It doesn't say graph it, but it'll be helpful for you in your own math classes at grade 10, 11 level to just be able to graph this function. And it's very simple to graph. So to graph a polynomial function, when I say polynomial, I'm talking about x to the power of n. Anything in this form, but that n has to be greater than equal to 1. and it can only be integers or whole numbers. X to the power of 0.5, this is not a polynomial. X to the power of -1, it's not a polynomial. This power has to be a number greater than 1, can also be equal to 1. In fact, it can also be equal to 0. So let me just put this 0. X to the power of 0 is a 1. This is a polynomial. If you want to graph that, it looks like this. Y equals 1. Goes through the y value of 1. So it has to be greater than or equal to 0 and has to be a whole number. Z there means an integer, which means it has to be a whole number. So x2, x3, x4, yada yada. Those are all polynomial functions. So how do you graph a polynomial function? You have to move everything, every term in the polynomial to one side of the equation. It's already on one side of the equation, so that's good. And you want to set that equal to 0. What are we doing right now? We're working on graphing that quadratic. Step number 1, move everything to one side. Step number 2, set it equal to 0. Step number 3 is going to be different depending on the polynomial function you have, but the goal is always to factor it. Some are easier than others. If you have a cubic function, anything more than power 2, then you have to do synthetic division by using the factor theorem, remainder theorem, in order to factor it. But quadratic is very simple to factor. How do we factor this function? What can we pull out? When I say factor, I mean what can we pull out, if anything?
X.
You can only pull out an x. You're left with 5x minus 8, like this. Now you have one term times the other term equal to 0. Now this is important. One term times another term equal to 0. What you can do is you can set those individual terms equal to 0. Like that. And when you do this, you will get the 2x intercepts. So one of them is 0 from the first term. The other one is 8 over 5, which is 1.6. So we have the 2x intercepts. Are we good so far? We're just trying to graph a quadratic, right? What's the y-intercept here?
-8.
No. Try again. It's not -8. Y-intercept is a constant that you add to the function, to any polynomial function. It's the constant c that we add at the end.
So it's 0.
It's 0. So this is going to go through the origin, okay? So we have 2x intercepts, x equals 0, x equals 1.6, and we know our y-intercept is also 0. So our function is going to go through the origin. Now the last thing you need is the vertex. You remember how to find the vertex of a quadratic function?
When the slope is 0.
When the slope is 0, that's right, but how do we get that point to begin with? You need to find h comma k is the vertex. Yeah, the slope will be 0, but we need to pinpoint where the slope will be 0. So we need to find the vertex. H is the midpoint of the 2x intercepts. So here, the x value of the vertex is 0 plus 1.6 over 2. That's 0.8. That's your h. K is the y value of the vertex. To find k, you need to plug h back into your original function. When I mean f of h, I mean we plug this 0.8 back into this. So it's going to be f of 0.8. So let me plug this x and this x as 0.8. 5 times 0.8 squared minus 8 times 0.8. That gives me -3.2. So now we have everything we need to be able to graph this quadratic function. And always graph it. I would always recommend at this level, just graph it out. So where do I graph this? I'm going to put it here. Or maybe actually I need more space. So 5x squared minus. So we have these three things. I'll put them down here. I'm going to make a nice sketch. So we know our function goes through the origin, x is 0, y is 0, right there. Another x-intercept is 1.6. Let's say this is 1. Let's say that's 2. I'm going to say this is 1.6. Again, you don't have to be super precise. The graphing here is just to get a good overview of where all the points and stuff are. And our y-intercept, sorry, not our y-intercept, the y value of the vertex. So 0.8 would somewhere be here. Our y value is -1, -2, -3, -3.2. Let's say that's right there. So now we have all our points. We can graph this polynomial. We know it's opening up. So boom, goes through the vertex and then comes right back through this other x-intercept. So there you go. That's our quadratic. It's a lot more curved here. It should be a lot more curved. So that is our function. Now let's start answering the questions. Question A. It says find, I can just move this down here. We don't need any of this anymore. Find the slope of the secant line that joins the point on the graph at x equals 2 and x equals 3. Now at x equals 2, this is our y value. At x equals 3, this is our y value. So what we're trying to do in part A is we're trying to find the slope of this green line. So it's asking us to find the secant line. The best way to do this is to find the y value at 2, the y value at 3, and then do rise over run. So what I'm going to do is I'm going to first find f of 2 and f of 3. Sorry, that was -2, so it was not 2, it was -2. So it should be coming -1, -2, so it should be coming this way actually. -2 is not on this graph, but it should be coming this way. Nothing really changes. You first find the y value at -2, then you find the y value at 3, and then you're just gonna do rise over run. So at -2, mental maths, if you plug -2 in here, what's the y value? So it's 5 times 4 plus 16, right? What is that?
36.
It's 36. That's why it was not on this page, because it's way off. And at 3 should be a number less than 5. So let's plug 3 in there. So it'll be 5 times 9, 45, right? Minus 8 times 3. So 45 minus 24. What's that? What is 45 minus 24?
It's 21.
21. So there we go. We have that point, -236. Actually, 3 is also not on this page, but it's at 3 and 21. Now we're trying to find the rise and run. So rise from 36 to 21. What's the rise? Positive,
15.
positive or -15?
Negative.
-15. From -2 to 3, be very careful here. From -2 to 3, what's the run?
It's 5.
It's 5. So your slope is 3. And there we go. That's the answer to this question. -3. That make sense?
Mm-hmm.
That's all there is, right? Part B is the exact same question. It's from -1 to 4. So we're not going to do it, but we're trying to find the slope of this line here. 4 is not on this page, but right there. Trying to find the slope, it's the same process. Find f -1, find 4, f of 4, and then just do rise over run, and it will give you the slope. The last part there, find an equation. This is going to be the tricky question. Find an equation for the line of change that's tangent to the graph at the function x equals 1. So at x equals 1, our tangent line would probably look something like this. Now the goal is to find the slope of the tangent line at that point. How do you find the slope of a tangent line? So this is a polynomial. There's two ways. I'm going to show you both ways. This method you have to know. It's very annoying, but you have to know the difference quotient method because this method is bulletproof. Eventually, when you get some complex function that may not have a shortcut. Polynomial, there is a shortcut, so we can do it that way. But difference quotient is bulletproof. You can use this anytime. What does it say? It says this. The slope, the IROC slope, IROC, instantaneous rate of change, is limit as h approaches 0 of x, f of x plus h minus f of x all over h, like that. So for this, what we need to find, h is h, so we're not concerned with h. We need to find f of x plus h and f of x. Our x value of interest is 1. So what this means is we need to find f of 1 and f of 1 plus h. So let me erase this, f of 1 plus, because that's our x value in question. So for this function, what's f of 1? This is f of x. 5x squared minus 8x. What would be f of 1?
-3.
Good, -3. F of 1 plus h. Now this one's tricky, but remember, all you're doing is you replace that x, those x's, with what you have in this bracket. So what does this become? So look at this. Okay, this is very easy. It looks complicated, but it's not. There's an x there, there's an x there. Wherever you see an x, when you're trying to do something like this, f of whatever, you're gonna replace those x's with what you have in this bracket. So this becomes 5. Well, 5 is not an x, so 5 is 5. But this x, look at this, it becomes 1 plus h. That x hasn't had a square, now this thing will have a squared. All we did was we replaced x with what we have in this bracket, minus 8 times 1 plus h. See that?
Mm-hmm.
What's 1 plus h whole squared? Is it 1 plus h squared? Or 1 squared plus h squared? Or is there something
1
else?
squared plus h.
It's not only 1 squared plus h squared. A plus b whole squared is going to be a squared plus 2 times the first term times the second term plus b squared. You might as well memorize this. This is very useful. And if there's a minus sign, the only thing that changes is the first plus becomes a minus. Everything else is exactly the same. We can prove
Okay.
this. How did I get that, right? Like you must be wondering, why is that? Because what we do is we FOIL it. A plus b whole squared is a plus b times a plus b. And then you FOIL it like this. A times a is a squared, a times b is ab. And then we've exhausted the first letter, we move on to the next term. B times a is ba, which is the exact same thing as ab. The order doesn't matter when we're multiplying things. These two are like terms. That's how we get a squared plus 2ab plus b squared. So here what we're gonna get is 1 plus, what did you tell me? 1 plus h whole squared is going to be what, using this formula? So this is your a, right? 1 is your a, and b is h.
It's gonna be 1 plus 2 times h.
Yeah.
Plus h squared.
Yeah, that And then we open this bracket, we get minus 8h. And here, this is just collecting like terms. It's not terribly difficult. So we FOIL this. Again, I'm going to show you how I FOIL it. Whenever you're FOIL, this is fairly simple because there's only one term on the outside. So you just exhaust it this way. When I say exhausted, I mean finish everything that's outside the bracket. Use everything outside the bracket. So 5 times 1 is a 5. 5 times 2h is 10h. 5 times h squared is 5h squared. And then we have minus 8 minus 8h. And again, we collect the like terms. 5 minus 8 is negative 3. 10h minus 8h is positive 2h. And 5h squared is 5h squared. Doesn't have any like terms. So there we go. This entire thing is the simplified bit of f1 plus h, okay? And now we're just going to plug it back into this equation. Limit h approaches 0. H, nothing has changed for these three things. F of 1 plus h is negative 3 plus 2h plus 5h squared. And f of negative 1 was negative 3. Now negative negative, this becomes a plus 3. And that's the beauty of this. When you do the difference quotient for a polynomial function, this does not apply to any other function, only for a polynomial function. Things will always cancel out. Always. Once you find your f1 plus h and f1 for a polynomial function, though, not for everything. For a polynomial function, things will always cancel out. So here, 3 and 3 gone. And now whatever's left, you can always pull an h out. That's the thing about polynomial function. Things will always cancel out, and once they cancel out, everything that you're left with, you can always pull out an h. So here, this becomes limit as h approaches 0, h 2 plus 5h all over h, like that. This h cancels out with this h. So then we have limit of h approaches 0 of 2 plus 5h. And that's the goal. The goal is to cancel out the h in the denominator. Once that h in the denominator is canceled, you can replace any other h. If you have any other h's, like we do here, we put in the value of 0 in there. So this becomes 2 plus 5 times 0, which is just 2. And there we go. That's the IROC for this function at x equals 1. Now that's using the difference quotient, which is always annoying. What's the derivative of this using the shortcut? Then this was the formula. You're going to get two terms. So for 5x squared, we bring the 2 down. It becomes 2 times 5 times x to the power of 1, right? What about for 8x? What's the derivative of 8x? Well, it has a power 1, so bring that down. It's 8 times 1 times, what's the new power of x? When you take 1 away
It's
from,
0.
it's
So
0.
x is just 1.
So this is 1, so that entire term, 8x, the derivative is 8, okay? For 5x squared, it's going to be 10x. So here we get 10x minus 8. So this is what we call the derivative function, or the IROC function. This is more powerful because using this method, we could have also done it down here if I didn't plug in the ones. It'll give you the IROC at any given x value for that function. So here, this way, this is only kind of useful for x equals 1. Like this way, if I asked you, what's the slope, what's the IROC when x is 2, then you have to do it all over again. But here, we only have to do this once. So when x is 1, you'll see that it's 10 times 1 minus 8. It's also 2. That's what we got here using the difference quotient. And there we go. But the question is not find the slope. The question is find the equation. So we found the slope. The slope is 2. Cool. Now we need to find the equation. So it's going to be in this form, y equals mx plus b. We found m, it's 2. So right now we have y equals 2x plus b. Now the question is, how do you find this y-intercept? We're trying to find the y-intercept of this line that just touches it at 1. I would not do this graphically because my graph is not perfect. Graphing quadratic is not always going to be perfect. So what we do is we know the x value. The x value is 1. We find the y value at that x value. So f of 1 was -3. So we also have the y value. Well, that's -3. Well, let's plug both of these in here and we'll solve for b. So it's -3 equals 2 times 1 plus b. So b is actually -5. So therefore, the final answer to this question, the equation of a line is y equals 2, because our slope is 2, x minus 5. That's the final answer for part C. So again, it's a little tricky, and you have to get used to doing it the difference quotient way. For a polynomial, it's not too hard. It's just foiling and collecting like terms. We will see in the next question where things become much more difficult. It says find the slope of the tangent line at the given point. So 3x plus 1, I don't know if you know how to graph this. We start here, 1 over x. 1 over x looks like this. Has a asymptote on the y-axis as well as the x-axis. Because y and x both can't be 0, otherwise you'd get infinite. So that's the parent function, 1 over x. It's called a reciprocal function. So compare this with this. Remember, x is the opposite. So x plus 1, you'd expect it to go 1 unit to the right. Actually goes 1 unit to the left. The 3 is just a stretch, not too concerned with that. So the x plus 1, what it does is it shifts the asymptote 1 unit to the left. So 3 plus x looks something like this. You can be more precise if you make a table of values. But the most important part here are the asymptotes. At 2, 1, let's say that's 2, 1, this is your tangent line. It's gonna be negative. The question is, well, what's the exact value of that slope of that tangent line? Is this a polynomial function?
No.
No, it's not. What's the name of this function? It says right there in red.
Reciprocal.
Reciprocal. So, which means you cannot use the shortcut method. Well, not directly anyways. So how do we find the slope of this? We have to use the difference quotient. Again, difference quotient, limit h approaches 0, f of x plus h minus f of x all over h. So what we need to find is we need to find f, what's the x value here?
2.
2. So we need to find f of x, so f of 2. That's simple. That's 3 over 3, right? That's a 1. So that's easy peasy. Okay, why don't you tell me what's f of 2 plus h for this function?
Three over 2 plus h plus 1.
Yeah, perfect. 3 over 2 plus h plus 1, and we can collect like terms. It becomes 3 over 3 plus h. Now here's a dumb question. Can we cancel out these 3's?
No.
No, you cannot, because there's a plus here. If they're being multiplied, yeah, sure. The plus minus cannot cancel out. Same thing if it's flipped upside down. Cannot cancel out these 3's. Common mistake. So we have both of them. Let's plug it in. The issue with non-polynomial function is that nothing cancels out. If it did, that would make life so much easier. For a polynomial function at this step, things always cancel out. You can pull out an h easy. Here, cannot, because nothing cancels out. There's only one thing you could do. How do we clean this up? We have a bunch of fractions, right? How do we clean up fractions? Because right now this is a little bit weird to work with. We need to simplify this a little bit. We take the LCD between these two, right? Whenever you have a fractions, just combine the denominator. Take the lowest common denominator and combine them. What's the LCD between 3 plus h and nothing?
3 plus 8.
Yes. So we multiply this with 3 plus h on the top and 3 plus h on the bottom. Now they have the same denominators. We can combine those two. So this becomes a big 3 plus h. And remember, there's a minus sign here. What does the numerator become? So minus 1 times 3 is like that, yeah?
And then you only have an 8.
We have a minus h. And then, so this right now is just f of x plus h. I didn't do the minus 1 thing, so we have a minus 1 in here, yeah?
Mhm.
Now what? Three minus 3 is gone, right?
Mhm.
Nothing is canceling out. Something should have canceled out, I think. Does this go to level 2 or level 3? The h at the very bottom.
Level 2.
Goes to level 2 here. There is something off. What did we mess up? 2 plus 1. Because right now, this h and this h, you can't cancel it. That was the purpose. That h should cancel, which means something is off here. 2 plus 1, 3. This is good. 3 over 2 plus h. 3 over 2 plus h. So 3 plus h, that's good. Okay, no, I get it, I get it. I added this extra. I added an extra one here for no reason. We already had the f of x, that's here. So this is 3 minus minus h. No, that's good. In the bottom we have this. Yeah, I get it, I get it. So this is what we had. This was 3 plus h, 3 over 3 plus h. This was just 1. We took the common denominator. We got this, which means we have a minus h on the top only. We don't have an h minus 1. Because the goal is to cancel out the h, and the only way that's going to work is if you have an h only term somewhere. So the minus 1 there being, it didn't work for a reason, because I added an extra 1 at the end needlessly. So there we go. This h and this h cancels out, right? That's the whole point.
Mhm.
So what are we left with here? We're left with negative 1 over 3 plus h. Now, once the h's cancel out, you're allowed to replace every other h with a 0. So this becomes a 0, ignore it. So therefore, the slope of the tangent line is negative 1 over 3. There we go. Cool?
Mhm.
So that's how you use difference quotient to deal with fractions. I'm going to show you another way to do this. I said before, polynomial has shortcuts, the other ones it's kind of tricky. It's because you have to turn them into polynomial form. What I'm going to do is I'm going to move this x plus 1 up top. What would I get if I move that x plus 1 in the numerator? What's going to be the power of x plus 1 if I moved it in the numerator?
-1.
-1, right? This is not a polynomial, but the rule applies. The shortcut method for polynomials also applies to this because this is in the form of k times x to the power of n. So the shortcut method is going to apply to this. So what does that mean? So you bring down the -1, it becomes 3 times -1 times x plus 1, and you take 1 away from that exponent. So -2, like that. So it's -3 over x plus 1 squared. That's the derivative function. So the shortcut also works for this because we can write this in this form, which is what the polynomial uses. Notice it's not a polynomial, but the shortcut also works as long as it's in this form. So now what? Now we just replace this with the x value. So look at this, -3 over 2 plus 1 squared. That's -3 over +9, and that reduces to -1 over 3. So there you go. Shortcut method, obviously super easy to use, quicker, but not always gonna work, okay? Does this make sense? Finding
Yeah.
IROC? This is the tricky thing, right? It's just the AROC, the average rate of change, is easy peasy. IROC is always the one that's more complicated. Let's see if we can figure it out for this. What kind of a function do we have here? Do you know the name for this function? So there's a square root, right? See that root? It's a square root function, easy peasy. But this is a square root function. This is a linear function by itself, but if it's in the denominator like c, we have a square root in the denominator in c, this is a rational or a reciprocal function. This is not a square root function. A square root function, square root of x, is continuous. It never stops. But this one, can x be -5? Would that give you a 0 in the denominator? It would, right? If x was -5 here, you would get a 0 in the denominator, which means it's not continuous. At -5, x cannot be -5. You have an asymptote. So it'd probably end up looking something like this. So that is a reciprocal or a rational function. But this one is a square root function. The +2, remember, it's the opposite. Does it move it to the left or to the right?
The right.
You'd expect it to be moved to the right, but it's the opposite. For x, it's the opposite. Someone once told me that x lies. Keep this in mind. When you're doing transformation, it's the opposite for x. For y's, it's the same. For example, if this was x plus 2 plus 1, then y would go by 1 up. It's as you see it, but x is the opposite. It's the opposite. So this goes to the left by 2 units. So how do we sketch this? It's very simple. Square root of x looks like this. This is square root of x by itself. The +2 moves it 2 units to the right. Sorry, to the left. To the left. So square root of x plus 2 would look like this. It just moves 2 units to the left, okay? Here it started off at 0, 0. Here it starts off at -2, 0. X lies. So there you go. That's a sketch of that. And they want the slope at -1. So let's say that's -1 right there. They want the slope of this tangent. Looks like it's going to be positive. Cool. So again, we're going to use the difference quotient method. Limit as h approaches 0, f of x plus h minus f of x all over h. So here, what's f of x, or f of negative 1? What is the value? Just put x as negative 1. Like that. It adds up to 1. What's the square root of 1? Square root of 1 is 1. So therefore, f of negative 1 is just a 1. What's f of negative 1 plus h, or f of x plus h? What would that be here?
Square root of negative 1 plus h plus 2.
Yeah. Again, collect like terms. 2 minus 1 is a 1, so you have square root of 1 plus h. There we go. Those are our two things that we're interested in. Good?
Mm-hmm.
From here is just a simplification process. F of x plus h is square root of 1 plus h minus f of x is positive 1 all over h. Now there's no fractions here, so we can't take the LCD approach. When you have a square root, whenever you're dealing with roots, to simplify it, you need to, and this is for roots, okay? It's for square roots, cube roots, doesn't matter. You need to multiply it by the conjugate. What's the conjugate of square root of 1 plus h minus 1? Do you remember? The conjugate of root x is root x. Original versus the conjugate. The conjugate of root x plus 1, well, it's itself. But the conjugate of square root of a plus square root of b is square root of a minus. The sign in the middle flips. So the conjugate of root 1 plus h minus 1 is root 1 plus h plus 1. Like this.
Mm-hmm.
We do this so that we can use a difference of squares in the numerator. Whenever you're multiplying by a conjugate, you have to do it in the numerator and the denominator. The exact same thing. So 1 plus h plus 1 in the numerator as well as the denominator. Now why? It's because this and this cancels up straight up. So essentially you're multiplying by a 1. So they need to be the same. Now what's the point of doing this? It's because we can use a difference of squares in the numerator. We have a minus b, we have a plus b. What's a minus b times a plus b? Difference of squares, it's a squared minus b squared. So here it'll be a squared, so 1 plus h squared, which is 1 plus h. The root and the square, they cancel out. So 1 plus h squared is 1 plus h minus what? What's b squared here?
It's 1.
It's 1. So now this and this cancels out. We have a h on the top and a h on the bottom. Can we cancel out these two h's?
Yes.
Yes. And every other h now is a 0. So this is a 0. So your final answer is going to be 1 over square root of 1 is 1 plus 1. So your answer is a half. 1 over 2. There we go. That's the slope. So that's how you want to deal when you have roots. You want to multiply it by the conjugate, and that's the only way you can simplify them. For fractions, the only way to simplify them is by taking LCD. Here, the only way is by multiplying by a conjugate. Otherwise, you're going to be stuck. If you don't know this, then you can't really simplify it any further. Now, there's a shortcut for this as well, as long as we can write it in the form. Can we write this in the form? Yes, we can. Square root, if I want to write that as an exponent, what's the exponent?
Negative.
It's just 1 over 2. Negative would be if it was in the denominator. Square root means to the power of 1 over 2. If it was in the denominator, then yeah, this would be x plus 2 to the negative 1 over 2. So this right now is positive exponent of 1 over 2. And now we're going to use the formula, the shortcut formula, g prime of x. You bring the exponent down, everything else stays exactly as it is, and you take 1 away from the exponent. So k times x to the n becomes k times n times x to the n minus 1. So you take 1 away from that, 1 over 2 minus 2 of minus 1, sorry. So this becomes 1 over 2. I'll show you the steps here. Negative 1 over 2. And that this term, you can throw it in the denominator to make it a positive exponent. So 1 over 2 x plus 2, 1 over 2. And we know to the power of 1 over 2 means a square root. So there you go. This is the derivative for that square root function. What we're going to do with this now is we just plug in the x value. What was the x value? It was negative 1. So we have 1 over 2 times negative 1 plus 1. Is that right? What does that give you in the denominator? If x were to be negative 1, right? What would that give you in the denominator? What's the denominator right now? I'll give you a 0 in the denominator, right? Do you see that?
Yeah.
But that's not what we had here. So what happened here? All right, I get it. Yeah, I forgot the minus sign. There's a minus sign here. Negative 1 plus h, negative 1 plus h, negative 1 plus h, negative, 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 negative 1 plus 0 plus 1. Yeah, so essentially what this means is that there is no derivative. Can you take the square root of a negative 1? What's the square root of a negative number?
You can't do.
You can't do this. It's I, okay, it's I, but we don't care about that. This is complex numbers. We don't do this at this level. But yeah, you can't take the square root of a negative number. We got a 0 in the denominator, cannot have a 0 in the denominator. What does all of this mean? It means that not everything has a derivative. Not everything has a derivative. Derivative means IROC. Not everything you can draw a tangent line, okay?
Mm-hmm.
Because the function that we had looked like this. Like over here, at this point, how would you draw the tangent line? It's very difficult at this point to draw the tangent line. Over here, it's easy, but over here, it's impossible. Not everything will have a tangent line. Here we have 2 minutes. We're gonna do something like this. Notice here f of x has 2 different parts. It has 2 different functions, right?
Mm-hmm.
What is this? If there are 2 different things assigned to the same y, this is y, f of x is y. This is called a piecewise function. Piecewise function. If it's made up of multiple pieces, it's a piecewise function. Let's graph this. So 4 minus x squared kind of looks like this. Positive 4 is the y-intercept. X squared looks like this. 4 minus x squared. But that function is only valid at 1 or less. So at 1, 4 minus 1, the y value is 3. 1 is inclusive, so that's a closed circle. So the first part of this function, 4 minus x squared, it looks like this. It has a y-intercept of 4, and at 1, the y value is 3. The second function, 2x plus 1, when the x value is 1, the y value is still 3, but with an open circle. But the closed circle here kind of fills up the openness of the second function. And the slope is 2, so 2 units up, 1 units across. This is our second function. And that's how you would graph a piecewise function. At -1, we're trying to find the slope of this line. So we use the top function. So we'll work with that. We'll do the limit x plus h equals whatever the formula for this function for part A, because that's the x value. For part B, the x value is 2. Actually, for part B, we don't even have to do any math. This line is 2x plus 1. What's the slope at x value of 2? What is the slope here? It's a straight line.
2x plus 1.
No, that's the
it's just
equation.
2?
It's just 2, exactly. For a straight line, we don't care. The slope will always be exactly what it was, okay? So slope everywhere from 2 to infinity. In fact, from greater than 1. When x is greater than 1, for this f of x, the slope will always be 2 because it's a straight line. But when x is less than 1, the slope will always change because you have a curve and you need to draw the tangents. All right, let's call it there for today.
Okay, thank you.
See ya.